Manufacturing has always been about precision. We need to shape materials accurately for countless applications. Traditional machining methods, while effective, have limitations. This is where electrical discharge machining, or EDM, comes in. EDM is a game changer, offering incredible precision and the ability to work with very hard materials. It's a non-traditional method that uses electrical discharges instead of cutting tools. Imagine cutting intricate shapes in hardened steel without any physical contact. EDM makes this possible. It's a process that removes material using controlled electrical sparks. These sparks occur in a small gap between an electrode and the workpiece, both submerged in a dielectric fluid. EDM has revolutionized various industries, from aerospace to medical. Its ability to create complex geometries and achieve tight tolerances is unmatched. Whether it's creating intricate molds or producing delicate medical devices, EDM plays a vital role in modern manufacturing. This essay will focus on a specific type of EDM, wire EDM. We'll delve into its workings, advantages, and applications, exploring how this technology is shaping the future of precision manufacturing. At its core, EDM harnesses the power of controlled electrical discharges to shape materials. This process is both fascinating and highly precise, making it invaluable in various industries. Imagine a miniature lightning bolt jumping between 2 points. This vivid imagery helps us understand the fundamental principle behind EDM. This is essentially what happens in EDM, albeit on a much smaller and controlled scale. The precision of this process allows for intricate designs and detailed work. The process involves 2 main components: an electrode, which is usually made of a conductive material like copper or graphite, and the workpiece, which is the material being machined. The choice of electrode material can affect the efficiency and quality of the machining process. Both are submerged in a dielectric fluid, which acts as an insulator and a coolant. This fluid is crucial as it helps to control the temperature and remove debris from the machining area. When a high voltage is applied between the electrode and the workpiece, a spark gap is created. This gap is where the magic happens, as it allows for the precise removal of material. The dielectric fluid breaks down in this gap, forming a plasma channel. This channel is essential for conducting electricity and facilitating the spark. This channel conducts electricity, and a spark jumps across the gap, eroding a tiny amount of material from the workpiece. This erosion is incredibly precise, allowing for detailed and accurate machining. This process repeats thousands of times per second, with the electrode gradually moving closer to the workpiece. The continuous sparking ensures that the material is consistently removed, shaping the workpiece as desired. As the sparks continue to erode material, the desired shape is achieved. This method allows for the creation of complex geometries that would be difficult to achieve with traditional machining techniques. The removed material is carried away by the dielectric fluid, ensuring a clean and precise cut. This fluid circulation is vital for maintaining the integrity of the machining process. The beauty of EDM lies in its ability to machine any conductive material, regardless of its hardness. This versatility makes it a go-to method for many industries. This makes it ideal for working with hardened steels, exotic alloys, and even materials like ceramics and carbides, which are difficult to machine using traditional methods. The precision and versatility of EDM open up a world of possibilities for modern manufacturing. Wire EDM is a specialized form of EDM that utilizes a thin, single-strand wire as the electrode. This wire, typically made of brass or molybdenum, is threaded through the workpiece and held taut between 2 guides. Unlike conventional EDM, where the electrode is pre-shaped to match the desired cut, wire EDM uses a continuously fed wire. This allows for the creation of intricate and complex shapes, as the wire can follow any programmed path. Imagine a hot knife cutting through butter. This analogy, although simplistic, gives a basic understanding of how wire EDM works. The wire, charged with electricity, acts as the hot knife, effortlessly slicing through the workpiece. The wire never actually touches the workpiece. Instead, it maintains a precise distance, controlled by a sophisticated computer numerical control, or CNC system. This ensures accuracy and repeatability, making wire EDM ideal for applications requiring extremely tight tolerances. From creating intricate molds for plastic injection molding to manufacturing complex medical implants, wire EDM's versatility and precision have made it an indispensable tool in numerous industries. Section 4. The Wire EDM Process, a step-by-step guide. Let's break down the wire EDM process into a series of easy-to-understand steps. This guide will help you grasp the intricacies of this advanced manufacturing technique. First, we have the setup. This is a crucial step where precision and attention to detail are paramount. The workpiece is securely mounted on the machine table and submerged in a tank filled with dielectric fluid. This fluid plays a vital role in the EDM process. The wire is threaded through the workpiece and tensioned between the upper and lower guides. Proper tensioning ensures stability and accuracy during cutting. Next, we move on to programming. This step involves inputting the desired cutting path into the CNC system. The desired cutting path is programmed into the CNC system. This program dictates the wire's movement, ensuring precise and repeatable cuts. Then comes spark generation, a fascinating part of the process. A high voltage is applied between the wire and the workpiece, creating a spark gap. This gap is where the magic happens. The dielectric fluid breaks down in this gap, facilitating the flow of electrical discharges. These discharges are responsible for eroding the material. After that, we have material removal. The sparks generated erode tiny amounts of material from the workpiece. Effectively cutting it along the programmed path. This process is repeated until the entire path is completed. The dielectric fluid flushes away the removed material, preventing debris buildup. This ensures a clean and efficient cutting process. Following this is wire feed. As the cutting process continues, the wire is continuously fed from a spool. This ensures a fresh cutting surface and maintains the accuracy of the cut. Finally, we reach completion. The final cut is made, and the workpiece is ready for the next steps. Once the wire has traversed the entire programmed path, the cut is complete. The operator then verifies the cut to ensure it meets the required specifications. The workpiece is removed from the machine, and any remaining burrs are typically removed using deburring techniques. This final step ensures a smooth and clean finish. Throughout the entire process, the CNC system precisely controls the wire's movement, spark gap, and other parameters, ensuring optimal cutting conditions and exceptional accuracy. This level of control is what makes wire EDM a preferred method for precision manufacturing. Section 5. Precision and Versatility. The Advantages of Wire EDM. Wire EDM boasts a range of advantages that have solidified its position as a go-to technology for precision manufacturing. First, unmatched precision. Wire EDM can achieve tolerances as tight as 1/10,000th of an inch, making it ideal for applications demanding extreme accuracy. This level of precision is crucial in industries where even the smallest deviation can lead to significant issues, such as aerospace and medical device manufacturing. Next, intricate geometry. The thin wire electrode and CNC control allow for the creation of complex shapes and intricate details that would be impossible with traditional machining methods. This capability opens up new possibilities for designers and engineers, enabling them to create parts with intricate internal features and fine details that were previously unattainable. Another key advantage is no heat-affected zone. Unlike traditional machining, wire EDM generates minimal heat, preventing warping or distortion of the workpiece, even with delicate materials. This is particularly important when working with materials that are sensitive to heat, such as certain alloys and composites. Material versatility is also a significant benefit. Wire EDM can machine any conductive material, regardless of its hardness, making it suitable for a wide range of metals, alloys, and even some ceramics. This versatility means that manufacturers can use wire EDM for a variety of projects, from cutting hard tool steels to machining softer, more delicate materials. Lastly, stress-free machining. As a non-contact process, wire EDM exerts minimal force on the workpiece, eliminating the risk of stress fractures or deformation, especially in brittle materials. This makes it an ideal choice for machining parts that require high structural integrity and precision. These advantages make wire EDM suitable for a wide range of applications, from creating delicate medical devices to manufacturing complex aerospace components. Its ability to produce high-precision parts with intricate details without causing heat damage or stress ensures that it remains a critical technology in modern manufacturing.